we will be considering bearings, and bearings are a way of telling directions. I am standing at a place where the sun rises from that direction, so that is east, this is west, this is north, and that way is south. Those are the four directions. And the east has nothing to do with my right arm, because if I turn this way, this would still be east, this would be south, north, and that would be west. Now, if I put directions, if this is north and this is east, we can look at this and we can see that we have something like a system of axes. So if I place labels on the directions, and this is north, then if I go back, you'll find that this is east, this is west, and this is south, if you can see it. Now, if I want to tell someone to go in a northerly direction, they would move along this line. And if somebody is to move along an easterly direction, they would move along this line in this direction. But if I want to go somewhere in between, how can I be precise? I can't just say northeast, because somewhere in between is northeast in the middle exactly, but if I want to go slightly more to the east or slightly more to the north, how can I specify that direction? What I can do is specify specific angles to each direction. So the north is 0 degrees. And if I turn clockwise, the east would be 90 degrees. The south would be 180 degrees. And finally, the west is 270 degrees. And if I continue my revolution, I will reach 0 again, which is the northerly direction. So I start by facing north, that's a bearing of 0. And if I turn clockwise, I would be facing east, that's a bearing of 90. This is a bearing of 180, that is south, and then a bearing of 270 facing west. And if I complete the revolution, I go back up to a bearing of 0 and not 360, because that's the northerly direction. So basically, if you want to represent this on a piece of paper, you would draw your axes in the normal way, representing the four directions. This is north, which as we have seen is at a bearing of 0 degrees. This is east, which is at a bearing of 90 degrees. This is south, a bearing of 180 degrees, and west is a bearing of 270 degrees. So if you are facing north and moving in this direction, in a northerly direction, you would be moving at a bearing of 0 degrees. Now if you turn and face east, then if you move in an easterly direction, you would be moving at a bearing of 90 degrees. If you turn by a further 90 degrees, you would be facing south, and moving in this direction means that you'll be moving at a bearing of 180 degrees. Another turn of 90 degrees to make you face west, and if you move in this direction, you will be moving at a bearing of 270 degrees. Finally, you complete your turn and you face north again, that's a bearing of 0 degrees. So let's say I want to move in a northerly direction. I would be moving along this line. However, if I was standing somewhere else, for example here, and I was supposed to be moving in a northerly direction as well, I would move along this line, and the two lines that I will be moving along in both directions will be both parallel. So the north direction is parallel for all the points in this area. So let's say that we have three people standing at three different places. A person is standing at A here, another is standing at B, and a third person is standing at C. For the person A, this is the direction of the north. For B, this is the direction of the north. And for C, this is the direction of the north. So if A moves at a bearing of 0, that is at a bearing of 0, meaning that in a northerly direction, and if B moves at a bearing of 0 in a northerly direction, he will follow this red arrow. And if C moves in a northerly direction at a bearing of 0, he would follow this red arrow. And as you can see, the three different paths are parallel. The same applies to any other direction. If this person moves eastwards at a bearing of 90 degrees, and this person moves eastwards at a bearing of 90 degrees, and this person moves eastwards at a bearing of 90 degrees, all the paths towards the east are parallel. And this holds for any other direction. As you can see, the mobile can tell me the bearings. So the direction now is towards the north and it's 0 degrees, and if I rotate it, I'll get to 90 degrees. That's bearing of 90, that's towards the east. Now I can say, okay, I want to move along a bearing of 30 degrees, and that would be closer to the north than the east, and that means that I'll be moving along that direction. So the bearing is the angle measured clockwise from the north. Now if I start at this point and I move at a bearing of 30 in this direction, and somebody else moves at a bearing of 30 as well, our paths will be parallel. So how can I sketch a path that represents a bearing of 30 degrees on paper? First of all, this is our 4 directions, and that's the point where one is standing. Keep in mind that a bearing is the angle measured clockwise from the north. So we can put a protractor, center it at the point where we're standing, and measure 30 degrees from the north. So that gives us a point here. We can remove the protractor. Let's fix our point first. The point is here. And then obviously the bearing of 30 is represented by this line. So if one is asked to move at a bearing of 30, or you want to describe a motion at a bearing of 30, then this is an angle of 30 degrees, and this path represents a bearing of 30. As you can see, this line is at a bearing of 67, so it makes an angle of 67 with the north. Now let's say I'm going to move a certain number of steps along this direction. I will start by facing north, then I will rotate by 67 degrees clockwise, and then I will move that specified number of steps along this line, and I'll reach my destination. Now let's say that at this point I need to change direction and move at a different bearing. So that, say that I'm going to move at a bearing of 120. At this point I change my bearing to be 120, so I rotate from north clockwise 120 degrees, and the direction is now determined by the arrow on the mobile, and I move along in this direction at a bearing of 120. So let's see how we represent such a journey on paper. We have a ship that sailed at a bearing of 67 degrees for 6 kilometers. Then it changed course to move at a bearing of 120 for 2 kilometers. So let's say that this is our initial position. This is where the ship was at the beginning, and obviously this direction is north. To move at a bearing of 67, we have said that we have to measure an angle of 67 clockwise from the north, and this is approximately something like this. This angle is 67 degrees and this length is 6 kilometers. Now the ship has reached this point. It will have to change course. So we imagine that there is another set of directions here. This is still north and this is east. Now a bearing of 120 goes beyond the east because a bearing of 90 is towards the east, so 120 takes you 30 degrees beyond the east. So this part of the journey can be represented by something like this, and this angle is 120 degrees because that's the bearing, and this length is 2 kilometers. So this is the end of the journey for this ship.